Hello, welcome all again to another live stream from our NVIDIA developer team. Thank you again for joining us this month and taking your time out of your busy day or night to join us wherever you are. Today we have a nice one for you. We've got a recap of everything and all announcements that we've released over the past few weeks. And we have a couple of experts as well coming to join us to talk about their respective disciplines. We're going to be talking about the Blackwell GeForce RTX series, talking about Project DIGITS. We're talking about launches for RTX PCs foundation models. We're talking about NVIDIA Drive AI systems and also NVIDIA, Siemens, Accenture rollout products and services for the next wave of industrial AI. I wanted to introduce first Anamali, or AC as we call him. He's going to be talking about AI foundation models for RTX PCs. So without further ado, AC, do you want to take it away?
Thanks, Zach. Hey, everyone. Super excited to talk to all of you about RTX AI PCs and what we have in store for you today. Next slide, please. All right. AI on PCs is one of the most important developments in technology, right? AI is being incorporated into every major app and will impact nearly every PC user. It all started about in 2018 when NVIDIA launched the first RTX GPU with dedicated AI hardware called Tensor Cores, alongside the first widely deployed PC AI called DLSS. DLSS enabled gamers to get up to 4x faster frame rates by using AI to generate pixels and frames in their gaming workloads. And since then, RTX has been at the forefront of innovating across AI for content creation, AI for video conferencing and live streaming, AI for streamed video, and AI for productivity. RTX AI PCs are available from every major OEM, and today we have an installed base of more than 100 million units shipped worldwide. There are also more than 600 AI-powered apps and games that are all accelerated on the RTX AI PC today. And now we're starting a new phase of PC AI. The technology is rapidly growing and expanding the capabilities and making AI super accessible to everyone. Next slide, please. So to address this new wave of PC AI, we're announcing NVIDIA NIM for RTX AI PCs and workstations. NVIDIA NIM microservices are these optimized and prepackaged models for generative AI that are ready to go out of the box. They're easy to download, and developers can easily connect to them via industry standard APIs. You can just click to install with a one-click installer, and they're ready to use on your PC. They span, the most important modalities for PC development and usage, and they're optimized by NVIDIA for optimal performance on the RTX GPU. They include both top models from NVIDIA as well as community-built models, and are compatible with the favorite tools of developers today to build workflows and applications. They can be deployed anywhere from PC to the data center to the cloud. And in fact, as you might know, NVIDIA NIM started first in the cloud and data center, where we've made it super easy for developers to deploy AI into their applications. And now we're bringing that same technology to RTX. This NIM will now help PC developers and enthusiasts get started with AI quickly, iterate quickly, and leverage and get the most out of their GeForce and RTX GPUs for AI workloads. Next slide, please. So now you might ask, what exactly is a NIM, right? What exactly is in a NIM? First, we've optimized the models themselves. We've curated the most important and the popular models from the AI community, as well as models made by NVIDIA, and we've quantized them and optimized them to run super fast on the PC with minimal memory. We've pre-built the engines for RTX GPUs so that they run optimally. The next is domain-specific code, right? You can't just take a model, connect it to an application, and expect it to work. It turns out that every model has many different, dependencies to libraries and software that are specific to each particular domain, because you have to pre-process the data, get it into the model, and then post-process the data before it gets kind of returned all back to the user. So all that logic, all that goodness is included in each NIM. Next, we also have the inference backends, right? That enables you to get the most out of your hardware. And some of our popular inference backends include TensorRT and TensorRT LLM, which are NVIDIA optimized for RTX GPUs. And oftentimes, models need to be customized for specific use cases and workflows. And NIM supports the usage of multiple model profiles for different situations. So a developer could, take the NIM container. They could, train it and fine tune the model with techniques like LoRa adapters. Next, we also have industry standard APIs that allow the AI tool ecosystem and the agentic ecosystem to connect directly to NIM microservices, so that you can run your favorite workflows and applications from your favorite developer tools. And finally, all of this is encapsulated in containers that makes them super easy to deploy on an RTX AI PC. These containers are validated across the suite of NVIDIA's platforms, and on RTX they run on top of Windows subsystem for Linux, so that you get to have one unified interface regardless of where you're developing, from the cloud to the PC. The whole point of NIM is that developers don't have to do all the groundwork to get their model up and running optimally on their hardware systems. We've made it easy, and with NIM you can just take the container and start building your custom applications and workflows to your needs. Next slide, please. So the initial wave of RTX NIM microservices is slated to come in February. As you can see, they include many well-known models and span many modalities, ranging from languages to RAG models to speech models for both automatic speech recognition and transcription, and also for modalities like animation and image generation. These models will all be permissively licensed, free use on RTX, and available to download and install, with many more coming in the upcoming months. Next slide, please. So NIM microservices are interesting by themselves, but they become even more useful when developers can start connecting the multiple of these NIMs together to build workflows. To address this, we're announcing NVIDIA AI Blueprints for RTX. AI Blueprints are developer reference projects and sample projects that show you how to work with NIM microservices to create your own custom AI experiences and workflows. They include everything that a developer needs to get started, including the code, the sample data, a reference application, as well as customization tools. And they're all optimized on the RTX platform. We have several of these blueprints that will be available shortly. Namely, one of them is PDF to podcast. Essentially, the idea is, a user uploads a PDF and we generate an AI generated podcast so that they can learn about topics on the go, on the fly. We also have other blueprints for digital humans, as well as 3D guided image generation to create images on the fly. Next slide, please. So all the NIMs and blueprints are coming soon to you in February. You can get started with NIMs and blueprints by going to build.nvidia.com, where you can experience many of these NIMs on the web. Then you can also download and run on your RTX PCs with a single one-click installer that sets up everything that you need on your PC and gets you running right away. Developers can also use them via AI Blueprints on NVIDIA AI Workbench, which is a tool for managing and sharing AI development projects across systems. You can also connect the NIM microservices and other functionalities to your favorite developer tools, be it low-code, no-code tools, or more robust tools to build agentic workflows using NIMs. And finally, with NVIDIA Digital Humans, you can connect it to a UI to build unique workflows and experiences as well. Next slide, please. So NIM on RTX is coming soon from all the top OEMs. We have a variety of modalities that we're supporting initially, spanning language, images, RAG, and speech, and more. And NIM is supported by many of our model partners, and it's supported also by our rich ecosystem of developer tools. And should you wish, you can also experience the power of NIM through experiences like anything LLM, Conf UI, and LM Studio, all right on your RTX PC. And this will be also available and supported with all the top OEMs. Next slide, please. So where does all this cool, exciting new software run on, right? One of our major announcements at CES was the RTX Blackwell 50 series GPUs. With over 92 billion transistors, the latest Blackwell 50 series GPUs represent the state-of-the-art compute capabilities on your PC. This generation of GPU has up to 4,000 AI TOPS of compute power to accelerate AI workloads. And on the top end SKU, we have over 32 gigs of VRAM available to run your AI workloads. It also has 380 RT T-flops, ray tracing T-flops, and 125 shader T-flops to accelerate your 3D and graphics workloads. And additionally, it comes with an AI management processor, which is a hardware scheduling module, which basically increases your AI performance when you're running multiple workloads on the GPU at the same time. This is great for situations where you need to run multiple AI models concurrently at the same time. For instance, you have a vision model running in the background. Next slide, please. So how can you kind of take advantage of the latest GPUs, right? NIMs and Blueprints are one exciting way, but this is also another way to add AI features to your apps on our latest GPUs. So this showcases the breadth of software that's available for developers to build AI into their apps. With this stack, developers can obtain maximum performance out of the latest Blackwell GPUs with foundational software and SDKs. At the foundation layer, we've updated our core software spanning from CUDA 12.8, which now has support for FP4 precision, to PyTorch, TensorRT, and community tools like ORT and Llama CPP to run your AI at peak performance. And we also have many SDKs that we've updated so that you can get the most out of your 3D and graphics workloads with DLSS and RTX Kit. For your generative AI workloads, we have SDKs like ACE, which help accelerate your digital humans, and we have Maxine and RTX Video for video streaming and broadcasting use cases. And all this software, some of these updates will be available shortly. Thanks, Zach.
Great. Thank you very much, AC. That was quite a bit of information. We do have questions that people can ask. We have a LinkedIn stream going on at the same time as this YouTube. So if you want to ask questions, we encourage you to go to the LinkedIn page to ask your questions. And I think some of our mods will try to share that in the chat. So if you can't see it, it is actually on the NVIDIA AI LinkedIn developer page. So if you do a quick search for that, you'll see this stream happening there as well. All right, next I'm going to introduce Chintan. He's going to be talking about agentic AI platforms and Nemotron.
Thanks, Zach. Can you hear me okay?
Yes.
All right. Can you go to the next slide? Yeah, so like Zach mentioned, I'm going to cover all the announcements that we did around agentic AI at CES. So, AI has just taken off, right? But if you think about it, each wave of AI has changed the way we have worked. In the late 2010s, it helped us identify objects. It helped us identify patterns, recognize patterns, and and find the best route optimizations so that we could be very productive with the work that we were doing back then. Then came ChatGPT and generative AI, and as a result came content generation, which just supercharged our productivity. And now we are in the age of agentic AI, where specialized digital humans are automating the task, which is going to make us, and as well as our organizations, hyper productive. Um, every industry has an amazing opportunity with agentic AI to leverage agentic AI. And the most amazing thing is that we are seeing the ecosystem as well as the AI community jump into this with both feet. Can you go to the next slide? Next slide, Zach. Oh, thank you. What is an AI agent and how does it work, right? An AI agent is an autonomous system that can understand what the users are asking. It can make decisions and it can perform tasks. Once once a prompt comes in, the AI agent will iteratively use the LLMs to identify what the plan is going to look like. It will identify the tools that will give it the best responses, and then it will go and fetch information from a different database, and then put all of that together. It will even critique the results or the task that it has to do, and then it will share that information back with the user, or it could be the case that it will share it with another agent. Next slide. So, so in a real world application, you will have a team of specialized agents working, all of them working together. So a real world example would be a software bug tracking agent that will connect to a bug database so that it can help the software engineer identify, prioritize the most important bugs for the day, and then even point to different reference codes that is causing the issue. Once the bug is addressed, the bug tracking agent can send that information to the technical documentation agent, who can automatically update the documentation. The bug tracking agent at the same time can also send information to the coding agent so that the coding agent can update that code in the GitLab. And then all of that will be orchestrated through an orchestration agent. So as you can see, this is, it is capable, these agents are capable of addressing some really complex tasks, but underneath it, under the hood, there are some great complex agents that are doing all the work together. So the question is, how is NVIDIA helping with this effort? If you can go to the next one. Yeah, so basically NVIDIA is offering building blocks so that you can build your AI agents. At the bottom are the NVIDIA NIMs, something that AC talked about quite in depth, but basically I'll up level it, where we're taking all the state-of-the-art models that are, open models that are built by the community, or we are building our own models, and we are optimizing it for performance, we're optimizing it for latency and throughput, packaging them up as NVIDIA NIM microservice, and then that makes it very easy for you to deploy it, whether it is on-prem, in the cloud, or on RTX systems. Now, once you deploy these NIMs into an agent, you also want to make sure that the agent stays up to date and constantly keeps learning, and that's where NeMo comes in. NeMo essentially allows you to curate these models, or curate the data as new data comes in. You get to curate the data with NeMo. You can customize the models or fine-tune the models with that curated data, You can evaluate the data to make sure that it meets your expectations and your benchmarks, and then you can guardrail the model to ensure that the agent will provide appropriate responses. And AC also covered NVIDIA AI Blueprints, and so at CES we announced a few agentic AI blueprints or blueprints for agentic AI, and I'll cover them in more details. But essentially, these are models these are blueprints that are meant to address specific tasks for a variety of use cases, whether it is for retail or for healthcare, for finance, etc. So let's go to the next slide. All right. So when you think about an advanced agentic AI system, they need to handle a variety of different tasks with precision, as well as they should be able to do it by working alongside alongside other agents. This basically means that the models or the agents need to be experts at a variety of different tasks. They also the complex agentic AI systems will also run a series of large language models, which means that they have to be extremely compute efficient. So at CES, we announced Llama Nemotron family. Basically, we are taking the amazing Llama models that Meta puts out, the open models that Meta puts out, and then we are improving the latency and improving the throughput by pruning these models, and then we are increasing the accuracy of these models by curating it or fine-tuning it with curated data sets. And so that addresses both problems of making sure that the agents provide the best results, but at the same time they provide the most of they provide the results faster. So the Llama Nemotron family will have three models. The first one is the Nano, which will be the most energy efficient, compute efficient model that you can deploy for real-time applications at the edge. The second is the Super, which will provide superior accuracy. It will basically be a balance of superior accuracy and exceptional throughput that you can run on a single GPU. And then the third one is the NeMo Ultra, which will provide highest accuracy for data center applications. Now, all of these models will be available as NIMs so that you can deploy them anywhere. All right, next slide. Like we hire and nurture our employees, companies in the future are going to build digital workflows that will need constant learning and improvement. And to do this, developers will have to build an AI flywheel that will basically help the agents continuously learn and improve their work. And to do this, NVIDIA offers, or to power this data flywheel, NVIDIA offers NeMo. So basically, the NeMo curator, which is a microservice, which is actually an SDK, helps you improve the accuracy of your models by taking the raw data and then extracting, deduplicating, and filtering that data, whether it's text, images, or videos, so that you end up with a high quality data that you can use to customize your models with Customizer. Once you have a fine-tuned model coming out of the Customizer, you can feed it into NeMo Evaluator, which will evaluate models on both industry standard benchmarks as well as your custom benchmarks that would relate to your project or to your application or to your enterprise. And then once that's done, you can apply guardrails, pretty comprehensive guardrails, without taking any hit onto the latency. So at the end of the day, you're still going to provide some amazing performance on your agentic AI systems as you constantly keep improving your flywheel and as new data comes in. Next slide. NeMo Retriever is a collection of generative AI microservices that connects your AI to your data. The collection includes industry-leading embedding models, re-ranking models, and it also includes a collection of models for ingesting large amounts of complex data. So why use NeMo Retriever? Well, NeMo Retriever provides world's best retrieval accuracy. It delivers 35% lower incorrect responses and up to 2x higher throughput compared to the next best alternative. It has 35 times improved storage efficiency, and it supports multimodal data. All right, next slide. Okay, so the third piece in that stack is the blueprints for agentic AI. So we have at CES, we released, like I said earlier, a handful of blueprints for building AI agents. And so some of these include research assistant agent for converting PDFs to podcast, similar to Notebook LM. It includes customer service agent for retail, software security agent that analyzes vulnerabilities, virtual lab agent for drug discovery, and video analytics agent for video search and summarization. Next slide. And we are working with a broad, taking a step back, right? Agentic AI is definitely a new and a very exciting field. Like I said earlier, everyone is jumping into it, and so we are making sure that we are not working in silo. We are working with a broad system of agentic AI ecosystem partners to make sure that you as a developer get the most out of this particular technology. So what I'm going to do, Zach, is I'm going to share my screen and just walk through a demo of where the developers or the audience can get access to all of the things that I talked about, as well as some of the things that that AC talked about too. So I'm gonna
Go ahead and share.
Share. All right, so if you go to build, can you see my screen?
Yes.
Okay, so if you go to build.nvidia.com, this is basically this is the NVIDIA API catalog. This is where you will find the models, you find the blueprints. So here's large language models, VLMs, retrieval that I talked about. There's embedding, re-ranking, ingestion models, and there's biology, speech, and science or scientific models. And so let's look at 405B as an example. So if you come to one of these models, these are all NIMs available here. You can try them directly. You can through the browser, or you can use the API. So you can use the API, connect your application to the NVIDIA hosted NIMs, and then try these NIMs at scale directly from your application. If you want to build this model, essentially, there are two ways. Like I said, there's the hosted API that I just talked about, and there's the self-hosted API, which means that you get to download the NIM and then run it in your secure environment. So once I say I want to download the NIM, I come here and I can get the container from here, and then move forward with building my application, deploying my application. And going back, so another thing that we talked about was blueprints. So here are a bunch of blueprints that NVIDIA offers. You can try them directly from here. So I'll take PDF data extraction blueprint here. And this is all presets. I upload, I extract data. So I've got 70 files that are being extracted. And now I can try these models. I'm going to just try, again, a preset example that gives you the answer, and then it tells you where it sorts that information from. Now, here's blueprint card that gets into the details of the architectural, or it provides architectural diagram of how this model was built, what the workflow looks like, what are the different models that were used to build this. So here is the retriever, or the embedding model, the retriever re-ranking model. Here's dplot to extract information from plots. Here is OCR model for extracting information from tables, and then all of that will essentially is being used by the large language model to generate the responses. Now, you can go and you can view the source code that is available on GitHub, and then you can take a step further, you can click on something called deploy launchables. Launchables is really amazing thing that NVIDIA has put out, where it essentially gives you a full instance with the GPUs and all the software that is required to run that specific blueprint. In other cases, there is workflows. So essentially, you can think of blueprints, but you can essentially run all of that from launchable. So I can click deploy, and then I forgot my credit card at home. Else I would have added money and actually have shown you how to run this. But essentially, you can try this yourself. All right, Zach, that's it for me.
Great, thanks, Chintan. That was very informative. Next, we did have a little bit of a technical hiccup, but our presenter, he's so dedicated that he's gone to his own recording studio and ready to share everything about the Cosmos world model with you. So, Mitesh?
All right, thanks. Yep, thank you. Can everybody hear me fine?
Yes.
Okay. Yeah. Sorry for the whole thing. I'm, as Zach mentioned, I'm in my own studio where I'm presenting from my car. So at
Soundproof.
CES we announced. Yep, indeed. At CES we announced a whole bunch of world model development platform in under the name of Cosmos. Now I'd like to talk, double click or go into more details of what is that platform all about, what are the models that we have released under that, and provide more details of how developers can use it and modify it further for various applications. You can go to the next slide, Zach. So as Chintan mentioned, it's not new news that LLMs and vision-based models have taken the world of AI by storm. In the past few years, we have seen a lot of applications in that domain. But the next obvious step is how can AI be enabled to solve more complex problem, and physical aware systems or physical AI-based system are the obvious next steps, where the systems are much more complex or the problems that we are solving are much more complex. So before diving in, what is physical AI? So physical AI enables autonomous machines to perceive, understand, and perform more complex actions in the real world. If you can think about use cases, as you can see in these images, these use cases are predominantly in the field of robotics, self-driving cars. You can think of those being applied in various application space like healthcare, manufacturing, and whatnot. And to succeed, or to have physical AI system to succeed, they have to be strong enough to or powerful enough to have a precise or deeper understanding of that environment, have the ability to balance themselves or have multi-dexterity. So if you're talking about a humanoid, and if I'm taking an object, passing an object from one hand to another, it becomes very it's a very difficult problem, and to solve that, you need these kinds of complex intelligent system that can understand and solve those problems. And go next slide, Zach. But as I mentioned, this problem is very complex and very hard to solve. So of course, these systems are incredibly difficult. And the biggest hurdle is the data. I'm going to start there. Data is very, very important because you need to teach these robots with all the edge cases that you can think about that they will perceive in real world. And this itself is a very, very hard problem to solve. So if you try to collect data manually, you will need to collect data through imitation learning systems. You need to set up those things in place, and it becomes the cost of collecting that data by itself grows exponentially because humans are required to teach or record data where you are imitating different tasks and all the edge cases. But then in certain scenarios, those edge cases are very hard to capture. A simple example would be in autonomous car domain, we want to capture data where there are accidents in place. So you cannot collect data where two cars are colliding with each other. You are making it, you are trying to collect data where two cars are colliding with each other. So those kinds of data set are other problem that you will models. So training these models are very, very resource intensive. So if you have large amount of data, you need the compute infrastructure and financial investment or commitment to train these large models. And then testing, once if you have these models developed, you need to test them in real world scenario. And that becomes very risky to start with, because you need to test for these edge cases, and they can they are dangerous if the models are not trained properly, and if sufficient safety measures are not taken into consideration when you're testing these systems in real world. From my experience, I'm a roboticist, and I have worked with ground robots, and oftentimes the robot will go into walls if I have not trained them properly, or if I have not trained the models properly. And these kinds of challenges are very normal, and you need to overcome those. Next slide, Zach. So to solve these challenges, we have built world models that are models that are capable to take into consideration the physics of the environment. These are neural networks, but much more complex, and are capable to learn like humans from real world data. And the goal of these models is to generate videos using using multimodality. It can be text, image, or video, and whatever prompts you are giving, it will generate videos of that sort. Or the other option is, in the robotic space, you are more interested in generating clips or videos, what is happening at T. So this has its own challenges. Are we good?
You went out and in for a second, but I think you're back now.
Okay. Yeah, apologies again. So to train these models, you need to add another layer of challenges, which is you need, as I mentioned before, you need petabytes of photorealistic data, which is very hard to collect to start with. And even if you have those footages available, the next set of challenges, you need to create this video data set. Remember, in the LM phase of if you are dealing with images or video clips, even a small clip of 10-second video will be in megabyte range. So you are dealing with data that is humongous inside, in petabyte range, give or take. You need to, and the second step you need to take into consideration is, while acquiring this data is difficult, you even need to another challenge that you have is filtering this data set so that you can curate it properly. If you have if you have a video clip that is giving the same information, that is not going to be helpful downstream to train your models. You need to have variety in your data set, and hence you need to curate your data set such that you have all the possible information as you need, but you don't overburden your data set with a lot of replicated information. And hence filtering your data set becomes equally important. As I mentioned before, the obvious step is training. These models are training intensive. If you're training a foundation model from scratch, you're talking about weeks and weeks of training on large compute infrastructure with GPUs having very large memory. And the last challenge that one will face is, even if you have these foundation models for downstream use cases, say for example you are trying to deploy in a warehouse environment, you might need to fine tune the model for policy or cost models, and that by itself you need in-house expertise who understand how to optimize those cost models and policy models. So if you club all these things together, it is very challenging to start with. Next slide, Zach. Okay, click all of them. I'll just talk through it. Yeah, so to resolve these challenges, we introduced NVIDIA Cosmos, or we announced NVIDIA Cosmos at CES, which is a World Foundation model development platform for advancing physical AI. So it consists of various components. Let me provide
Mitesh, I think you're coming in and out. Perhaps turning off your video might help a little bit. Again, apologies. His brand new setup in his professional recording studio. He's still getting used to it.
Are we good?
Yes.
Can you hear me? Okay.
Yes.
Okay. So we announced two World Foundation models. One is diffusion based, the other one is autoregressive. So diffusion based models takes multimodal, is capable to take multimodal input in terms of text, image, and video, and the output is a high fidelity video which is generated using the model, and the prompts are a reference image that you have provided. With autoregressive model, the goal of this model is to generate images that are is to generate images that are that is the potential next state of a video sequence given the current video state that you are in and the text input that you have provided. A simple example would be if I give a prompt that navigate from the drawing room to the kitchen. So the robot will be navigating from the drawing room to the kitchen, and in order to do that, you will need the current place of where you are. So if you are in the drawing room, the next frame will be the robot has moved slightly, walking towards the drawing room. At T+1, if it's at the door of the drawing room, it will go into the hallway based on the floor plan of the house. Then the next step would be going through the hallway and then going into the kitchen. So you'll have to create this sequence of images based on your current state of where you are. And the current state is perceived by these models in form of the video that it has already generated. So it is generating a sequence of images based on the input that you have provided and how you will do a task of going from the drawing room to the kitchen. So these are the models. The other thing that we announced was the tokenizer. So tokenizer are equally important. Remember when I explained you that with images and video, you are dealing with petabytes of data set. So tokenizer is nothing but a compressed way or a compression model that compresses the raw data from its actual form into tokens, which is very small in size, and it captures all the important information such that you can generate the same image if you detokenize it. So if you think about training large models, training models with
You're breaking up again, Mitesh, a bit. I think it's still going in and out.
Can you hear me?
Yes.
Okay. I'm going to turn off my video just to make sure the feed is going through and we don't have interruption. Okay, and finally, beyond tokenizer, the last component that is part of this video foundation model platform is the video curation pipeline. So you need to have an efficient pipeline to process your data even before you can think of training large model or fine-tuning this large model. So along with announcing these models, the tokenizer, we've also announced a video curation pipeline that is very well defined how you can process images or video data set. And this becomes very efficient because oftentimes people discard how complex data processing is, regardless of text or image, even before you can train or fine-tune your model. And lastly, guardrails. Guardrails is equally important because remember, these are generative platforms. So so you need to provide guardrails both from a text standpoint as well as the generation standpoint, so that you are masking the faces or you are blocking images that are that does not pass the filters of NSFW. Okay, diving, double clicking a bit on
You're breaking up a little bit again, Mitesh.
And the past video frame for context. Okay, I'll start again. So you can go to the next slide, please. Zach, can you go to the next slide, please? Okay, so I'm double clicking quickly on each of these models. So the autoregressive models are meant to predict the future video frames with higher precision and speed using the input, that is text, images, and the past video frames. These architectures are tailored for physical AI use cases, and it enhances control in generation, and it has got a lot of goodies in terms of cross-attention layers to improve comprehension and normalization techniques so that stability is improved. The Cosmos super models, I'll be telling the different family of models that we have announced, but the models have different types. They're ranging from 4 billion and 12 billion parameter model that can predict 24 frames in the future from 9 input frames of the past history, and the 5 billion and the 13 billion parameter model that are capable to predict 32 frames in the future from the text and the current video frames. Next slide, please, Zach. Okay, the other one is the diffusion model. So these models are similar to autoregressive model with a slight differentiation. They operate within the learned latent space by refining random noise and generate high fidelity videos from text, image, or video inputs. Just like autoregressive models, this model architecture is also meant to enhance for generating physics-aware video, and it adds all the advanced techniques in terms of efficient spatial and temporal processing, making sure the encoding and precision are capable to generate videos with different resolution, and have cross-attention layers to make sure it aligns with the textual input as well. So you can think of when to use autoregressive model or when to use diffusion model. How to think about it is, if you want high fidelity video that needs to be generated, you can think of using the diffusion model. On the contrary, if you care about what is the next frame going to look like based on where I am today or where my current frame is, and based on the context that I have given, what will the next frame look like, then you should, if that's the application, in most situation in robotic space or self-driving space, those are the applications that you will think of. You can think of using autoregressive model for those kinds of use cases. Next slide, please. And then, of course, guardrails. So we have also released Cosmos guardrails, which is, again, a dedicated neural network, which improves safety by filtering the input prompts and blocking unsafe outputs. So it has got blockers on both sides, on the input side as well as on the output side. So guardrail becomes important if you are developing an application. You should add guardrail to your models before deploying the model, so that you are ensuring the generations are safe and consistent. Next slide, please. Okay, so at CES we announced the three families of model. One is the Nano, Super, and Ultra. Super is available today that you can download from Hugging Face or build.nvidia.com. The same link that Chintan shared. If you search for a Cosmos diffusion or Cosmos autoregressive model, you should be able to find those models as well. You can download those models and you can play with them, use them as is for video generation, or you can use this model as baseline and fine tune it down further for your downstream application. We will also be releasing Nano and Ultra in due course. You can think of these models for different use cases. If you are trying to deploy a model on an edge device, think of using Nano, because then real-time inferencing becomes very important. If your super models are baseline models that are designed for versatility, whereas Ultra models are high-performing model, and it predominantly focus on generating videos which has got very high fidelity. And very important to add, all these models are openly
Hey, Mitesh, you're breaking up again.
where did you where did I get cut off?
About 5 seconds ago.
Okay, so yes, so so Cosmos supermodels, they are available today, available to download on Hugging Face and NVIDIA API catalog. Next slide, please. So the other component that I talked about was data curation. So we have also released NeMo Curator for video processing, and this is a fully GPU accelerated video processing pipeline that can curate your data set regardless of what the format is. So as I mentioned before, even if you have 20 million hours of video, you are looking at 35 petabytes. That is huge. So you need to make sure you are curating this data you have efficient data curation pipeline such that it is able to consume this 35 petabyte of data in an efficient manner and produce an output or tokenize your data such that it is very easy it is reasonably easy for training or fine-tuning your model. So what does data curation pipeline include? So this is the workflow that you can see as far as a video processing pipeline is concerned. So it consists of different blocks. One is the video decoding and splitting block. The other one is transcoding, where you convert all the short videos into consistent format. The middle block is the filtering block, where you want to process your clips for specific characteristics or filter for specific characteristics, such as if there is a motion blur, if there is watermark, if there is visual quality issues in the clip, there are text in the video clip, or there are or if there are proprietary logos. You might want based on the applications that you are working on, you might need to remove these kinds of data from your
We lost you again. Remove data.
No, I stopped because I saw. Yeah, so you can remove this data based on the downstream use cases that you're working on. The last step is annotation. Once you have filtered your data set out, you need to annotate this data, because training any diffusion model, you need a pair of your visual data set with what is that clip about, description of that clip. So you need to annotate your data set. So we also have captioning models, which are state-of-the-art vision language models that you can use for captioning these models. And once you have those captioning, you need to embed those models or tokenize the video and the text using different embedding models. You can use Cosmos Tokenizer to tokenize your image part, and you can use any other text embedding model to embed the text part of the image and the text clip. Next slide, please. And then, and as I mentioned, we also released the tokenizer model. So oftentimes people might think that what is a tokenizer? So a tokenizer is a compact way, as I mentioned before, a compact way of representing raw data set. So with Cosmos Tokenizer, you have 8x compression from the raw data set, and when you and it reconstructs the same image that you compress with the with the encoder piece, which is 12x faster compared to the state-of-the-art tokenizers that are available out there today. The tokenizer model are very easy to use. Again, they are available on GitHub. The code base is available on GitHub, and the models are available on Hugging Face for you to download. There are different types of tokenization models that we have released that has got different resolution in terms of compression, as well as tokenization. So there is continuous tokenization as well as discrete tokenization. So you can go to the next slide, Zach. So this is how a tokenizer works. So as an input, it will take a video or image, and then it will encode them into latent space. But those are nothing but tokens. Both these, we support both discrete and continuous tokenization. Again, based on the use case that you're working on, you can think of which tokenization is important for you. The tokenizers are such that it takes into consideration the temporal consistency as well as the spatial consistency. So it can tokenize both a video input feed as well as a static image, and to handle both these use cases, we have different tokenization. Next slide, please, Zach. Okay, last but not least,
We lost you again at the start of the clip.
Okay, I'm going to start again. Yep, I'm going to start again. This is my second last slide, so I should be okay. So this is so once you have your foundation model, we have provided those foundation model. But say for example, you want to fine tune it or customize it for your downstream application. It can be a warehouse application. It can be for agricultural robotics. It can be for self-driving car. But you need to customize it further for your downstream application. And in order to do that, you can leverage NeMo framework, which has got all the important algorithms that you can think of within NeMo framework, and it is an efficient pipeline where you can fine tune your model at scale. Next. Okay, so this is the last thing.
We lost you again.
The Cosmos World Foundation model that we have released.
I think we lost you again, Mitesh.
Okay, where do you lose me? Should I start again?
Yes.
Okay, so this is the last slide. So with NeMo, framework, developers can build their own World Foundation model, or they can customize the Cosmos World Foundation model and build their own policy models with NeMo framework. NeMo framework has got a lot of capabilities. It provides it has multimodal support, so it is capable to take text, speech, images, and video as input. It has got efficient data loading strategies, so it reduces a lot of overheads that you can think about when you are training or fine-tuning model with large amounts of data set. It has got a lot of acceleration goodies under the hood with different parallelism. Some of them are pipeline parallelism. Layers of the model are split across GPUs for efficiency. Tensor parallelism to fit large models across GPUs and efficiently use GPU memory. Data parallelism, again, if you have large amounts of data, how you can train it with relatively small models. So all parallelism, all
You cut out.
And last but not the least, NeMo framework. Okay, did you hear anything about parallelism?
Just a bit.
Can you hear me now?
Yes, now we can.
Okay.
I think you are cutting out. I think maybe Chintan can chime in on the last part.
Can you hear me now? Zach, can you hear me?
Yes, we can.
Okay, so it provides four different types of parallelism: pipeline parallelism, tensor parallelism, data parallelism, and context parallelism. Each of these parallelism that it provides has advantages of its own. So if if you have pipeline parallelism, you can deploy layers of your model across GPUs. Tensor parallelism can help fit large models across GPUs and efficiently use the GPU memory so that you are training or fine-tuning your model much more efficiently. And NeMo framework also provides in-frame inferencing as well, which is something new that we have introduced. So thanks for bearing with me. Apologies for all the internet breakout.
Thanks, Mitesh. Yes, please.
Platform was
I think
Yep.
his recording
Thank you.
studio. I think his recording studio is, going through some growing pains. But appreciate everyone's understanding, and thank you for joining us again. All right, so we have our final presenter. We've gone over a little bit, but we're going to stick around and go through the Q&A. So I will let Alan go and talk about Project DIGITS.
Thanks, Zach. Why don't we jump in and go right to the next slide? So at CES, Jensen announced NVIDIA's Project DIGITS. It's a very small desktop system powered by our new GB10 Grace Blackwell super chip. And the essence of the product is it's a personal AI supercomputer for your desk. And the goal is to bring the power of Grace Blackwell to millions of developers. And so it's very small, very tiny. It provides a petaflop of AI performance at FP4 precision. And with 128 gigabytes of coherent unified memory, you can work with AI models up to 200 billion parameters at your desk. So it can work with really large AI models in an incredibly small form factor. The picture gives you a rough idea of the size, but if you kind of want to get a better idea, take your favorite coffee mug, maybe from the edge of the mug to the edge of the handle. That's about how wide it is, and maybe about half as tall. So it's a very tiny form factor. If you've got a chance to check it out at CES, it's very small. And it's designed for a specific set of users. It's not for everyone, not really a general purpose computer, but it's designed for AI developers, researchers, data scientists, and students that are working with AI and workloads that includes very large models that have traditionally required cloud or data center resources. And along the bottom, we've listed out some of the workloads that we think are really going to be suitable for Project DIGITS. And these include, of course, working with AI model development, experimenting, and prototyping. You can do fine tuning here. Models up to 70 billion parameters should be really good for tuning exercises on this system. For AI inference, for testing, evaluating models, or perhaps running your own local AI inferencing models, perhaps your own chatbots or code copilots there on your desktop. Data scientists can take advantage of it. They can access our full rapid suite for accelerated in data science software stacks and workflows there. It's also, we think, a great development platform for edge applications. It's going to support all of our frameworks and toolkits, things like Isaac, Metropolis, many others. So it's a great platform for developing those edge application, things like for robotics, computer vision, maybe VLMs. So essentially, anybody doing AI development could use Project DIGITS on their desktop to complement your current data center or cloud resources, or perhaps you've got a laptop or a system that you need to go off that device to do some of the work you're doing today, work with larger models. So you can actually have a DIGITS on your desk and use that as your own private cloud or data center to send your compute, or perhaps even to run AI models. We talked about those code copilots or chatbots and other agents, maybe for your own personal use, so you can run those there locally on your desktop. Let's jump to the next slide. And at the heart of DIGITS is, of course, that GB10 Grace Blackwell super chip that we also introduced. It's based on our Grace Blackwell architecture. This variant of it is optimized for desktop systems, and it's that power of Grace Blackwell that gives us that incredible performance in that very small form factor. If we take a little closer look at some of the components of the system, the GB10 is a Grace CPU with 20 ARM cores. The Blackwell GPU includes our latest generation tensor cores. That's where we get the FP4 data format support, but it also has a full bank of RT cores, CUDA cores. So it is capable of running all of the RTX stack, all the graphics and rendering as well. The CPU and GPU are connected via our NVLink C2C technology, so we've got high-speed connection between the cores. We mentioned the 128 gigabytes of memory before. It's fully coherent and shared between the CPU and GPU, and so that's what lets us run those large models. We also have a ConnectX chip on board the system for high-speed networking, and it also lets you pair up two of these Project DIGITS systems through that ConnectX link, so you can run very large models, potentially up to 405 billion models, taking advantage of the combined systems. We've got a full set of additional connectivity, so it's got Wi-Fi, Bluetooth, up to 400 terabytes of local storage, so you can connect mouse and keyboard locally and use it as a standalone system if you'd like. The OS is going to be a full version of our NVIDIA DGX base OS. That is an Ubuntu Linux base OS. It's going to come fully configured with a full stack of our AI software. So if you're familiar with our DGX environment, it should be easy for you to move over to here and also use any of your favorite local tools in that environment. So kind of in summary, we're kind of short on time, but it's really a supercomputer on your desk. We want to give a really engaging experience for developers. So if you're doing AI development, research, even students, hopefully you'll be able to use these and continue to push the boundaries of generative AI. Project DIGITS is going to be available starting in May at a price starting at $3,000 US. You can sign up to be notified when DIGITS are available at the Project DIGITS webpage. You can easily find it. We've got a rotator on the NVIDIA.com page. You'll see DIGITS come up and you can click on it there. And of course, join us at GTC in March for the latest on Project DIGITS and everything NVIDIA live and event or virtually if you can't make it in person. So with that, I'll throw it back over to you, Zach.
Thank you very much, Alan. And thanks to all the speakers for sharing all that information. It was quite a bit of a deep dive. Speaking about GTC, let me share a bit of information. And bring that up. So as you know, GTC is our annual GPU technology conference. It's happening in March. Today or ongoing, we have a 20% discount code for you to apply for registering. You can, if you can't get to the link there, there's the URL. You can just enter this discount code GTC25 WShack. All right, I'm going to go through some of these questions. There were some that we weren't able to capture specifically, but there is, I think, one question about NIM support on older Ada RTX GPUs, and I think AC can chime in about that question.
Yeah, thanks for that question. I think we recommend generally our Ada cards, Ada generation, and our 40 series up GPUs, which have at least 12 gigs of VRAM in them. Of course, it would depend on the specific NIM and blueprint. Some NIMs require larger VRAM, have larger VRAM constraints. So not every blueprint and NIM will work on those cards, but generally we recommend Ada cards up, which have at least 12 gigs of VRAM in them.
Great, thanks, AC. We do have one question here that is directed at Chintan. Can go ahead and put that up on the screen.
Yeah, I can connect with.
Oh, Chintan, you weren't on this up yet. So do you mind going through and starting from the beginning?
Oh, okay. Murray, thanks for asking the question. I don't know the answer to this, but if you can connect with me on LinkedIn, I will connect you to the right person who can help answer that question.
Great, thanks. Another question that was brought up is NVIDIA Workbench downloadable?
Yeah, I can try taking that one. So NVIDIA AI Workbench is our is available today. So you can go on our NVIDIA.com website and search for Workbench, and you'll get to a landing page where you'll be able to download that tool on your system, be it a Mac environment or Linux desktop or even a Windows desktop. Essentially, what AI Workbench is, it offers a development environment manager for folks to build AI workflows on GPUs. It can connect to both a remote instance on the cloud or data center, or a remote workstation, as well as run locally if you have a GPU-enabled system. It essentially kind of helps you manage your containers, environment, and config in one single VM or pane. And you can run kind of your Python workloads on top of it. You can also connect it to your GitHub projects, so that you have one unified environment, and you can migrate across data center to PC to workstation. And we also have sample example projects for Workbench available on GitHub, for RAG, for fine-tuning kind of workflows, as well as other cool projects that you can go explore.
Great, thanks, AC. We have a few other questions we can get to. I think this is kind of like a more of a general question. Attempting to proliferate AI while developing intelligent apps like LLMs, Gen AI, or AI models, how do we ensure ethics and safety?
I think guardrails are extremely important, right? And fortunately, guardrails are not just limited to ethics and safety, but that is a great way to start. Can you hear me? Can you hear me, Zach?
Yes.
Oh, okay. Yeah. So, there are a lot of solutions that are out there. There is no silver bullet, but one way to look at it is basically looking at all the guardrails related solutions out there would be a great starting point. I think obviously NeMo guardrails that we offer is available on GitHub as an SDK that you can start with. We have also announced today actually that there are 3 additional models that are going live, so you can take a look at those and see if that would fit your need.
Great. Maybe a few more questions. There is one about, is ASL A, B, C, and D a world standard for the Western Hemisphere?
I'm not sure what that's referring to.
Is that something, Daniel, if you're around, can you elaborate on that? Else we can jump to another question. We do have a question here about, it's quite general, about, this is more, I think, about gaming. With all this technology being available for game engines, Unreal Engine and Unity, I think, without speculating, there are things in development from our game development team, and just keep an eye out for announcements upcoming. Generally, GDC would be the best time frame to tune in to see any kind of advancements and announcements in game engines. All right, we've actually gone over quite a little bit. There are some questions, but that's all the time we have for. If you want to continue the conversation, please go to our NVIDIA developer Discord and ask there. Also, we have NVIDIA forums. We'll try to link them everywhere in the stream. And yeah, keep an eye out for future posts on live streams. We continue to have them at a more regular cadence to answer any of your questions. And please join us at GTC if you can with the discount code link. Thanks for joining us, and we'll see you next time.